All right, hey gang. Got word earlier this afternoon that we are going to be canceled tomorrow, which I kind of was a little surprised at. It looked beautiful outside today. Did a lot of moving snow on my driveway and everything, and not a lot of wind, which was nice. But I think it has to do with the extreme cold that we're going to have between today and tomorrow. And so, going to get ready and kind of give you your first blizzard bag. So my plan is to kind of back up everything that we were planning for Tuesday and Wednesday. So on Tuesday, we were planning on having another review day for the test on Wednesday. Well, now it's going to be Thursday and Friday. Review on Thursday, test on Friday. So what I was planning for Thursday originally is now going to become your, I guess it'll be Wednesday assignment here. And it's actually an introduction into the next chapter. And so as we get started with this next chapter, what we're going to be dealing with are similar figures, okay? So what is a similar figure? Well, similar figures have the same shape, but not the same size, if that makes sense, okay? So what are we really talking about? You can kind of see it up here in the corner of our first lesson, dilations. Dilations are similar figures. When I think about a dilation, there's a couple of stories that come to mind. The first story has to do with my 16th birthday. I know a lot of you are turning 16 if you're not already 16 within the next year or two, and it's an exciting time of life. My parents, being the highly successful farmers that they were, they got me a Corvette for my birthday. Now the Corvette looked somewhat similar to the one I'm going to hold up here in my hands. Okay, this guy right here, this is a Corvette. Actually, it was a Ferrari. Now that I think about it, I've got what is this? A Shelby GT. Those either are motorheads. Okay, pretty nice vehicles here. But yeah, that looked kind of like mine. It was just a toy car on top of my cake. Congratulations, Brandon. You got a Ferrari. So, anyways, the reason why I've held on to these. I went out and purchased these when I first started teaching is because these are dilations from the actual shape. If you'll notice here in the upper corner, where's that? If you look right over here, okay, it talks about a scale factor. Now the scale factor here is 1 to 64, which means if I take every dimension of this car right here, if I was to take the diameter of the tire and multiply it by 64 times, or the length of the car and multiply it by 64 times, I have the actual shape of the original Corvette. Okay, so the reason why I can tell it's a Corvette is because it looks like one. It's just a smaller version of the original. Okay, same thing with this one right here. This one's a little bit bigger, so I expect the scale factor to be a little bit smaller. Instead of being 1 to 64. There we go, right? Oh, where's that? Right there in the corner. You can kind of see it right there. It says 1 to 32, so it's literally twice the size of my original one that I showed you. And again, every dimension in this car, which is absolutely sweet looking, I can multiply by 32 and I would have the original shape of the original car, okay? The other story that comes to mind, when I think of a dilation, I think of my eyes. How many of you have ever been to the eye doctors before and had your pupils dilated? I never had that done until I was like 27, 28. I started to get an eye condition, which I still have to this day. No, actually it was probably in my 30s, 30, 31. I never had my eyes dilated before. And so I went across town, I think it was across town, my eye doctor at the time, and he goes, all right, we're going to dilate your eyes. And I'm like, okay, what does that entail? And okay, this is what we're going to do, okay. And so he dilates my eyes. I have to come back and teach. I have to come back and teach in front of a projector. Those of you that have had your eyes dilated know how incredibly sensitive to light your eyes are. So I came back and I taught with my shades on that day in front of the projector. So, but a couple of years ago, I was talking to my class in front of the class and saying, okay, what do you guys think of when you think of dilations? And I'm thinking to myself, I'm thinking, they're going to say eyes. Everybody, it's the easiest thing to think of, your eyes. They're dilated, right? I had a young lady in the back of the class raise her hand. She never spoke much, didn't answer many questions, and I'm thinking to myself, yes, I like it when I get students involved. So I called on her. I said, Bryn, what do you got for us? And she says to me, she goes, I think of babies. At that moment, I did not know how to respond. I was completely tongue-tied. She was exactly right. Dilations are a part of the birthing process. And I didn't know how to respond. I was like, you are so correct. But I was not going to go into details as to why she was correct. Now, if you've ever been caught off guard, embarrassed in front of people, didn't know what to say, that was me, okay? And so if you're not understanding why dilations are a part of the birthing process, talk to your mom and dad. This should be a normal conversation. What happens, why dilations are part of the birthing process. I'm not going to explain it to you. I don't think I should have to. So anyways, those are my stories. I hope you enjoyed them. All right, so let's talk about dilations here. What my game plan is to go over kind of the front side here and maybe introduce a little bit of the back side and then explain what I'd like you guys to do for me to finish up this this lesson considering the dilations. So I'm just going to read through the first part here with you and maybe comment on a couple things, and then we'll go from there. So it says, a dilation is a similarity transformation. So it's not what we called earlier rigid motion. If you remember, rigid motion was it's the exact same shape and size. Everything's congruent. It's a similarity transformation that enlarges. Okay, so it's key. It's either going to get bigger or reduces or gets smaller a figure proportionally. Okay, proportionally means at the same rate. At the same rate. Okay, we're going to use that word an awful lot over the course of this chapter here, so you're going to become very familiar with what it means to be proportional. Dilations are completed with respects to the center point and a scale factor. Okay, now remember what a factor is, how many times bigger or smaller it is, what you would multiply it by to get it bigger or smaller. Okay, sometimes we call it scale factor. Sometimes we call it an R value. Why is it called an R value? I'm not sure, but that's it's like a letter they use for scale factor. So let's talk about the scale factor, which is the same as an R value. Not to be confused with your house's R value, which is how much insulation you have. So the higher the R value in your house, the more insulated it is, the more resistant it is to weather changes, temperature changes. Okay, so scale factor or the R value. If the scale factor is greater than 1, okay, bigger than 1, then that's an enlargement. Okay, we'll talk about that in a second. If it's less than 1, it is a reduction, meaning it's getting smaller. Okay, so greater than 1, if you think of 1 as 100%, 1 would be 100%, so it's equal. That would be congruent. If anything has a scale factor of 1 or an R value of 1, the two figures are congruent to each other. But if it's greater than 1, then it's going to be bigger. If it's less than 1, it's going to be smaller. So if you take a look down here, we'll just drop down to number 1. It says, use a ruler to draw an image of the figure under a dilation with the center S and scale factor R indicated. Okay, I went ahead and drew this already. I was going to give us this after the test and wanted to just kind of show you what this looks like. What I did is I took my ruler and I went ahead and drew out the distance here, the distance here, and the distance here. Okay, I just drew random lines from the center of dilation through each of the points of the initial triangle. Okay, and the next thing I did, I took my compass. I got my compass here. I took my compass and I measured this length to one of the points. So in this case, to point R. Okay. Since the R value over here is 2, it's going to be twice the size. It's going to be doubled. So I'm going to take this initial distance and double it. So I went over here and made another marking at twice the size. Okay. So there's my R value, or my next spot. So this is twice the length from the initial center of dilation. I went ahead to T and to Q and did the same thing, those same distances out here. And at those new points, I went ahead and drew them in. Now, one of the things I want you to get in the habit of doing is, does your bigger triangle look the same as your smaller triangle, just at an increased size? And that's what we're hoping to see if we do it correctly, okay? Now, for the second example down here, it's hard to see because my C prime runs into it, but the R value is 1/2, which means that my new figure should be half the size of the original figure. Again, when it's less than 1, it's a reduction. When it's greater than 1, it's an enlargement. So I went ahead and drew each of these lines through my center of dilation. I then measured this length here, and then took half of it and made that length right there, made a mark at half. Did the same thing here at half, did the same thing here at half, and did the same thing here at a half, and then just connected them. And if you were to measure these out, now, depending on how precise I was, I'll use centimeters here. This looks like maybe 13 millimeters. No, 21 millimeters, sorry. And if I go out here, this should be about 42 millimeters. Looks like it's a little bit bigger, maybe 43. But what I want you to see there, let's see here. Yeah, it's probably more like 22, so it's 44. Yeah, 43, 44. And so, again, this length doubled gives us this length right here, okay? So the big thing I want you to get from the front side is this. All of your constructions, okay, there could be a question on a test that says, where is the center of dilation? So all you have to do is draw through the 2 points, draw through these 2 points, draw through these 2 points, and these lines should go back to that center of dilation. Now that brings up a good point. A lot of you have been through art class already, and I don't know if you have done perspective drawings. Perspective drawings always go back to a center of dilation, or that was 1 point and 2 point perspective. The vanishing point, I think, is what they call it in the perspective drawings. That's exactly the same thing that we're talking about here, okay? So everything within the dilations is going to go back to the center of dilation. So it's pretty simple to find if you have drawn your lines correctly, where they all come together, okay? So let's take a look at the back side here. We're actually going to go ahead and draw a center of dilation. Okay, I'm sorry. We're actually going to draw figures that are going to be similar. Okay, let's see if I can get this to look a little bit clearer. There you go. Okay. Now, for the first one, I'm going to draw out the initial points. So E is at -2, -2. F is at -2, 1, 2, 3, 4. At 2, 1, 2, 3, 4, and H is at 2, -2. So E, F, G, and H. Okay. If we go ahead and connect those, okay. Now from here, you notice the R value is 0.5. Now in each of these, graph the image of each polygon with the given vertices after a dilation centered at the origin. Centered at the origin, okay, with the given scale factor. So all of these is going to have a center of dilation at the origin. Now I will tell you this, I'm going to show you number 3 here in just a second. And I'm actually going to do it with the center of dilation at a different point. I'll fix that over here, but just to show you how the concept still plays out, excuse me. So here's how I work this out. I'm going to start at my center of dilation, and I'm going to do the rise and run to one of these points. So the rise would be down 2, left 2. So 2, 2, okay? Now, if it's half of that distance, instead of going 2, 2, I'm going to go half, 1, 1. And that point right there is going to be E prime, okay? Instead of going 1, 2, 3, 4 and over 2, I'm going to go up 2 and over 1. And that'll be F prime, okay? This one is up 4 over 2, so I'm going to go up 2 over 1. Again, I'm going half of those distances. And then down 2 over 2, I'm going to go down 1 over 1. This will be H prime, okay? So what do I know about this new rectangle? Well, there's a couple of things that we should observe here. The first thing is this. Each of the dimensions should be half as big. So if I go from E to F, 1, 2, 3, 4, 5, 6, so that's a length of 6. This is 1, 2, 3. This is a length of 3. That's good, because this one should be half as big as this one, okay? This one is length of 1, 2, 3, 4. So this one is length of 2. Again, this one is half as big as that one, okay? So I hope you're seeing how dimensionally it's half as big, okay? The other thing I want you to see is we talked about how all these points lead back to the vanishing point, the center of dilation. If you notice here, if I go ahead and draw in through my points, okay, they all lead back to the origin. Okay? And so that's what makes it nice. Everything leads back to that center of dilation. Okay? So let's take a look at this next one in number 3. I have -2, -2. There's A. -1, 2. There's B. 2, 1, and there's C. Okay? So we have this triangle right here. Now, I want to change the center of dilation. Let me get that marked out there. Oh, that was kind of nasty. Try that again. There we go. Okay. So I'm going to make the center of dilation now on these next two down here, 3 and 4, you can just make the center of dilation the origin, okay? But I'm going to change the center of dilation to, let's make it 1, -2. Okay, so here's my center of dilation, okay? And it has an R value of 2, so I should be making this twice as big, okay? So I'm going to go left 1, 2, 3. Well, if I'm going to go twice as much, 1, 2, 3, 4, 5, 6, that new point right there is going to be where A prime is at. To get to C, I'm going to go right 1 and up 1, 2, 3. So C prime is going to be at right 2, up 1, 2, 3, 4, 5, 6. Now I just thought of something that if this helps you out better, if it's twice as much, I'm going to go over 1, up 3, over 1, up 3. Okay? That might help you just as much. 1, 2, 3, 1, 2, 3. Okay? Up 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2. B is off the graph here, but that's okay. And now we have our new triangle. All right, so I told you before we can check to make sure that, that this is actually twice as big. Here's how I would check that. Up 1, 1, 2, 3. Up 2 over 1, 2, 3, 4, 5, 6. So each dimension was doubled. This one is up 1, 2, 3 over 1, 2, 3, 4. From A to C, up 3 over 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Again, each dimension was doubled to get to that new point. And so I hope you see that this new triangle is twice the size of the original triangle. Okay? We could also go ahead and draw on our lines here through each of the points. Boom. If I go down here to B and B prime, look at how it all leads back to the center of dilation. Okay? So I hope you can see that there. So what I want you guys to do, now don't be intimidated by 1/3. You're just going to multiply the two distances by 1 over 3. My guess down here when you get to this one is there might be a fraction that you're going to have to graph, like 1 1/3, and you'll just have to estimate where that's at. Okay? So just keep that in mind. Hopefully that doesn't blow your mind at all. So here's what I want you to do to finish up. I want you to go ahead and finish up the last two graphs here, numbers 3 and 4. Okay? And then what I want you to do next is if you go to Schoology, you also have 3 questions from 498, 31, 32, and 37. Now my guess is that those are probably graphing problems. So you want to go ahead and graph those out for me. And then, then you're done. So you basically have 5 questions to finish up. I hope that was completely understandable. If you have questions, get in touch with me. Otherwise, thank you for listening and have a great snow day.